Hey everyone, it's Paul Bertorelli reporting from AirVenture in Oshkosh, where this year Engineered Propulsion Systems is back with its new diesel engine. Here are the details.
The Graflight engine we are displaying here is what we call a V8 180 degrees. It's basically a horizontal arrangement, but from an engine-specific perspective, it's still a V 180 degrees. The fact there is that one crank pin is sharing two connecting rods, and therefore the engine builds shorter and therefore saves weight, which is a key point in the design of an engine. The ferro core, the iron core, or Graflight as we call it, is describing one of the key elements we have in our engine, which is also a patented feature. So we are trying to come up with similar materials throughout the main components, which is the crankshaft, connecting rod, piston, cylinder block, and this allows us to operate basically in every climate without any loss of tolerances or clearances, which is great in terms of wear and tear if you think about from that perspective. We have reached several thousand hours of test cell testing. We actually completed a very important test we are fulfilling through one of the Air Force contracts we have at this point in time. We were testing in an altitude test cell at the Arnold's Air Force Base for more than 90 hours. In this environment, we tested the engine from sea level up to 30,000 feet. We tested it in several altitude elements and were able to double check the functionality of our software, and we were able to double check the combustion quality of our engine. Therefore, we know at this point in time that anytime we would put this engine into an aircraft, we wouldn't harm any pilots just because we can operate from sea level to 30,000 K without any incidences. We are expecting to fly the engine towards the fall. We are working on an integration in the Cirrus SR22 at this point in time and an integration into GA8. These are candidates that are easier to obtain because we don't have to go in structural rework. So these are prime candidates for us from an STC perspective. The certification testing is basically at the earliest beginnings at this point in time. We have done some testing in the past couple of months. The durability testing will basically commence after the EAA as soon as the full mechanical content of the engine is going to be available. We have been testing the EECS, which is our engine electronic control system, which contains the fuel system and the EECU already for a couple of months, and also successfully at the Arnold's Air Force Base. We can scale the horsepower output of our engine basically from any horsepower at the low end to up to 450 horsepower at the high end. Currently, from an STC, not from an STC, from a FAA certification perspective, we are testing to 385 horsepower. At the Arnold's Air Force Base, we demonstrated 408 horsepower in the test cell configuration. This is all based on also the turbocharger configuration we have. This was done with a low altitude turbocharger configuration. With a high altitude turbocharger configuration, it's going to be different. Well, any high performance twin application is a target area. Any single high performance single is going to be a target area. We see mainly inquiries from people who use our engine in a commercial way, so not the average flyer who flies maybe 40 hours a year. There it probably wouldn't make sense to convert something over or buy an extra new aircraft at that point in time, but people who can benefit from the cost savings flying this engine just because of its low ownership cost and operating costs is going to be attracted by this engine. So to give you an idea, a year back, fuel prices calculation, you could save almost the cost of the engine over the lifetime of 2,000 to 3,000 hours TBO in fuel savings if you would fly our engine, which is a significant saving.